Good morning. I am E. Ilavenil, and today we are going to start the engineering mechanics lecture series with the first topic, that is particle statics. Mechanics. First of all, we'll see what is mechanics. Mechanics is the study of force and its effects on the body on which it acts. Force is basically an action that tends to move a body in its direction. So when we say a force is acting on a body, that force tends or tries to move it. So here it may or may not move the body. It is the tendency which is important. That is, the force tries to move, and whether the body moves or not, it is studied under mechanics. The study of force and its effect on stationary bodies is called statics. So as told earlier, a force has a tendency to move, but the body need not move. So here, when the body doesn't move and when it is stationary, we study that force and we call it statics. So here, when we say the force is acting upon and there is no movement, what is the effect of a force? When we ask, it is a reaction that is created on the body. So the reaction is another force which is going to be created because of the applied force or the applied set of forces. So forces can have components which are going to join together to represent that single force, whereas several forces when joined together gives us resultants which create the same effect as that of the cumulative individual effect of each force. So here we study Newton's first law, which is crucial for statics. So according to Newton's first law, every body continues to be in the form of rest or uniform motion unless it is disturbed by an external force. So with this law, we get that unless disturbed by a force, a body should be under rest if it was originally at rest. And of course, it continues to be in uniform motion if it is originally moving. So when we study about forces and its effects, a force is definitely going to disturb this rest. So when we say at the absence of force we have rest, the force would be absent because of the cumulative action of several forces together, or else when we apply a force, the body cannot be in rest. So here we go for the concept of inertia which can be considered a sort of corollary from Newton's first law. So the concept of inertia is that every body has an ability to continue at its state, whether it is rest or motion. So this ability is crucial in sustaining the rest or the uniform motion at the absence of a force, or even there is a tendency to maintain the same condition even at the presence of a force which tries to change this. So this Newton's first law, as told, is applied at statics, and it is very crucial that we see Newton's first law as an essential condition for studying statics. Similarly, Newton's third law is also equally important in the study of statics. So according to Newton's third law, for every action there is an equal and opposite reaction, as we simply say it. Along with the equal and opposite nature of the reaction, it must also have collinearity. That is, when we have a particular direction or line of action for a particular force, the reaction is also along the same line of action but with opposite direction, and as mentioned, its magnitude is equal to the applied force. So this is again very crucial in the study of statics because it is the Newton's third law which says there is an equal and opposite reaction, and that reaction is the effect of any applied force. And in statics we study force and its effects. That means the applied force and the reaction is what we study in statics, and that is explained with magnitude, direction and line of action by Newton's third law. Engineering mechanics idealization. So here we often refer to study of particles and rigid bodies in engineering mechanics. So the actual particle is a point mass which has a dimensions negligible, that is infinitesimally small, as we call it. That is what we say particle. However, we idealize for engineering purpose particle which is not based on size but based on the force concurrence. We call a body as a particle when all the forces acting on that body are concurrent, or otherwise we say it means there is no moment acting on the body. Then we idealize it as a particle. Of course, in case of dynamics, when there is no rotation in the body, again that is another consideration for being a particle. So a typical example of a particle under engineering mechanics idealization is a bus traveling from one city to another. So normally for this study, we mark one city or one bus stand as a point and another bus stand or another city as another point, and the bus travels through a path which is marked as a straight line. So here bus is clearly considered as a particle. Okay, of course I am giving a kinematic example, but that clearly puts on that it is not the size which decides whether something is a particle or not. Again, another example we can consider is study of planetary motion. Planets are marked as points, or even whether we draw it a little larger or smaller, the dimensions are not considered when we go for studying the planetary motion along their path. But of course, when we study planet rotation, it cannot be considered a particle. Of course, we also consider one such similar idealization for rigid bodies, which we will see a little later. So as we study force, we'll just see what force is. So force is an action that tends to move a body along its direction. So a force contains a definite magnitude, which is the value with which it is going to act, that it is going to tend to move, and it has a definite direction, and it acts at a given point of application. So a force is characterized by all these three things: magnitude, direction, and point of application, which means force is a vector quantity. And here two forces are said to be equal only when their magnitudes are equal, along with their directions being equal, along with the point of application being same. Otherwise, two forces with equal magnitude, same direction, with some other point of application is not the same force, because it cannot give the same effect. Similarly, same magnitude, same point of application, and different direction is also a different force. Obviously, a force with different magnitude is also a different force. The SI unit of force is newtons, which is denoted by capital N. So these forces can be single or a number of forces which are studied together. So in the case of particles, there are a number of forces, whereas in case of rigid bodies, there are a number of forces and some moments, which together are called as force systems. So it is this effect of forces and the force systems that we study in particle statics. Thank you.